Hi everyone, welcome back. Today is like our third day on simplifying trigonometric functions. All right, so we're going to get into some of the more difficult simplification of expressions today. But first off, we've got number 1 and 2. Just to refresh your memory, we've got secant squared of x minus 1 all over tangent of x. So this is a Pythagorean theorem identity. You should know by now, and that would be equal to tangent squared of x divided by tangent of x. And tangent squared of x divided by tangent is just tangent of x. Nice easy one to start off with. And number 2, you want to be able to recognize that as other Pythagorean theorem identities, top and bottom. You take our Pythagorean theorem identity of sine squared of x plus cosine squared of x is equal to 1 and manipulate that a little bit, and you'll see cosine squared of x minus 1 is just equal to negative sine squared of x. And in the denominator, your sine squared of x minus 1 is equal to negative cosine squared of x. And so take and replace those. You've got negative sine squared of x divided by negative cosine squared of x. And lo and behold, that is just tangent squared of x. Now, number 3. To me, the way I look at this one for number 3 is I'm going to switch everything to cosine because secant is just a reciprocal of cosine, so it sort of makes sense. Maybe a nice starting spot. So cosine of x times 1 over cosine of x minus cosine of x. Now remember, when you have fractions, you probably want to combine them, make common denominators. So in that set of parentheses, that could be written as common denominators of cosine of x. So I would technically have to multiply my second fraction by cosine of x. So that becomes 1 minus cosine squared of x, which is forcing an identity to happen, and also my cosine of x's will cancel. So you should recognize that as Pythagorean theorem identity by this point, and you're left with just sine squared of x as your answer. All right, number 4, I'm going to switch everything to sine and cosine. So cotangent is cosine of x divided by your sine of x multiplied by sine of x over cosine of x plus cosine of x divided by sine of x. Now, you kind of have one of two options. You can combine your fraction in the parentheses, or I think what I'm going to try is to just distribute so you can see how that would work. Because the first distribute cosine of x over sine of x times sine of x over cosine of x, well, that just simplifies to be 1, plus distribute your cosine of x over sine of x, and you get cosine squared of x over sine squared of x, which now at this point, you also have a few options, right? Kind of what I see is that this guy is just cotangent squared of x plus 1, and that's your good old Pythagorean theorem identity of 1 plus cotangent squared of x is just equal to cosecant squared of x. So there are a bunch of different ways to do that number 4. Again, if you did something different but still can end up at cosecant squared of x, you're probably on the right track. Number 5, you've got tangent of x plus cotangent of x over cotangent of x. All right, you guys, this would be illegal. Do not just cancel out that cotangent of x. All right, that would be illegal. I'm going to switch everything to sine and cosine. So we've got sine of x over cosine of x plus cosine of x over sine of x, all divided by cotangent, which is cosine of x over sine of x. All right, let's make our common denominators to add our fractions. So make common denominators. Your common denominator would be sine of x times cosine of x. So this guy needs a sine of x times sine of x. Over here you need cosine of x, cosine of x. And you're left with, in that numerator, sine squared of x over, let me write that nicer, sorry. So sine squared of x over sine of x cosine of x plus sine of x cosine of x cosine squared of x. And I'm going to just break up that fraction, go divided by your cosine of x over sine of x. And I'm going to combine my addition before I divide. So I've got sine of x cosine of x sine squared of x plus cosine squared of x. And we can multiply by the reciprocal over here. So multiply sine of x over cosine of x. All right, and of course you should spot this Pythagorean theorem identity of sine squared of x plus cosine squared of x. So that would be 1 over sine of x cosine of x times sine of x over cosine of x. All right, and your sines will cancel, and you're left with 1 over cosine squared of x, which is secant squared of x. All right, number 6. I'll change colors, so we'll go in blue, or darker or lighter blue. Number 6, we've got tangent. This one's actually pretty close to number 5. It'll work out similar. So tangent, we're going to change to sine of x over cosine of x. And then the denominator would just be sine of x over cosine of x plus cosine of x over sine of x. Make common denominators in that denominator. So sine of x over cosine of x divided by, it's super similar, so I'm just going to write, after I make common denominators, I get a common denominator of sine of x, cosine of x, and your numerator would just be your sine squared of x plus cosine squared of x. And that would simplify to be 1 right here. That's your good old Pythagorean theorem identity. So sine of x divided by cosine of x divided by 1 over sine of x cosine of x multiplied by your reciprocal. You've got over 1. So your cosines cancel out here, and you're left with sine squared of x. So that's kind of like a second example of that number 5. Okay, number 7. We've got secant of x, cotangent of x minus cotangent of x, cosine of x. I'm just going to stick with what we've been working with, switch everything to a sine and cosine. So secant is 1 over cosine of x multiplied by cosine of x divided by sine of x minus cotangent, which is cosine of x over sine of x times your cosine of x. Now, what we have, let's combine a little bit. We've got cosines that are dropping out 1 over sine of x minus cosine of x squared divided by sine of x. So now we have common denominators. So let's just subtract across the top 1 minus cosine squared of x over sine of x. All right, and I identify 1 minus cosine squared of x. That's your Pythagorean theorem identity. And you get sine squared of x divided by sine of x, which works itself all the way down to sine of x. Number 8, let's see. One option that I want to point out is you have, we could have done it on number 7. You saw a GCF of cotangent of x that you could take out first. So I'm going to show you that technique over here on number 8. So let's take out tangent of x as a GCF. So tangent of x multiplied by sine of x minus cosecant of x. And I'm just going to switch that to my cosecant as 1 over sine. And at this point, I'm thinking I want to combine that fraction. So I'm going to combine sine of x minus 1 over sine of x. So that would just be tangent of x times sine squared of x minus 1 over sine of x after I got common denominators. And in the numerator, that is forced to be another Pythagorean identity, kind of a version of it. So it's like the opposite version. So -1 plus sine squared of x is just negative cosine squared of x. So all over sine of x multiplied by your tangent. And we know our sines will cancel if you change tangent to sine of x over cosine of x minus, all right, and you'll see some stuff drops out. Cosine, and one of those cosines drop out. Sines cancel. You're left with just negative cosine of x. A whole lot more simpler than where we started with. All right, and our last one for today, I want to show you a little technique when you see that squared. Just FOIL it. So you would end up with 2 sine of x cosine of x. Now FOIL sine of x minus cosine of x squared, first outer inner last. So the expansion there would just be sine, actually I'll change colors so you can see the expansion. So sine squared of x minus 2 sine of x cosine of x plus cosine squared of x all over, I guess I'll go back to blue, all over your secant of x. All right, and simplify your numerator. Those two will drop out, and lo and behold, you've got sine squared of x plus cosine squared of x all over secant of x, which simplifies to just be your Pythagorean theorem identity up top, 1 over secant of x, which is just cosine of x. All right, and that's enough for today. We'll move on soon. All right, so hang in there. We're almost to summer. All right, miss you all and see you soon.